in this lesson, we're going to be factoring trinomials. It's really important that when you factor trinomials that you first have them in standard form, where they look something like this. 4x squared plus 7x plus 2, something like this, where your variables, your x squared is first, it's your quadratic term, your linear term, and then your constant, okay? So that's the type we're going to be looking at in this video. So far you've looked at factoring out the greatest common factor, then you saw the dots pattern, or difference of two squares, where this splits into a plus b times a minus b. And now we're going to look at trinomials. Specifically, let's first look at this form, in the form of ax squared plus bx plus c, where a is 1. So let's look at the trinomial x squared plus 8x plus 12. There are many ways to factor this. A quick YouTube search will reveal a lot of ways, but we're going to do this with a tic-tac-toe board. Here's what you do. Across the top of the tic-tac-toe board, put your first term, your last term, and then your middle term is your checking term. In the bottom part of the board, you're going to put factors, or things that multiply together to give you this top row. So the only way I'm going to get x squared is if I take x times x. Now, factors of 12, and that's positive 12, could be 1 times 12, 2 times 6, and 3 times 4. I suggest you start with the two closest together, the 3 and the 4 first. That would be positive 3 and positive 4. Then you multiply straight across. X times 3 is 3x, x times 4 is 4x, and you check. This is the only place you add. Does that add to 8x? Nope, it adds to 7x. So what's that mean? It's not 3 and 4. So what do? Well, we have to back up and do a little erasing here. So it's always a good idea to do these with pencil. All right, since it's not 3 and 4. Next I'm going to try 2 and 6. So 2 here, and 2 times 6 gives me 12. Multiply across 2x, 6x, and I check by adding. Does that equal 8x? Yes, it does. All right, so I've got my answer, but where is it? It's not just this board, okay? You win on the diagonal, my favorite way to win in tic-tac-toe. So my first one is x plus 2, my first factor. And my second factor is right here on this diagonal, x plus 6. Now, just remember, you can always check this to make sure it works by distributing. Make sure that if you multiplied everything together, that would give me x squared plus 6x plus 2x plus 12. Combine my middle terms, and I do get what I started with. All right, let's do one more in the front of this graphic organizer. So let's try x squared plus 3x minus 18. So in your setup, first term, last term, and the middle term is my checking term. So sometimes I even put a little CK above this to remind me that that's my checking. Okay, so x squared. The only way I'm going to get x squared is if I take x times x. Now, factors of 18. So my factors of 18 would be 1 times 18, 2 times 9, 3 times 6. Again, I always start with my two closest to each other, 3 times 6. So I'm going to put 3 and 6. And 3 times 6 is positive 18. I need it to be negative 18. So I'm going to make one of these be negative. So I'm going to make this one positive and this one negative. Now, the more you do, you're going to get better at spotting what it needs to be ahead of time. I multiply straight across. That gives me 3x and negative 6x. And then I check. Does that add to give me my top term here of positive 3x? Well, negative 6x plus 3x is negative 3x. Well, I'm really close. Okay, so when that happens, and your signs are just flip-flopped, all you need to do is come right here and switch which one's positive and which one's negative. So I'm just going to take my eraser tool here and switch out my signs. So I'm going to make my top one negative, my bottom one positive, which makes it like this. Now when I add, I do get positive 3x. So what are my factors? Right here is 1, x plus 6 times the quantity of x minus 3. Okay, once in a while kids ask me, does it matter if I write x plus 6 first or x minus 3? No, because 4 times 5 is the same as 5 times 4. The commutative property applies, and it applies to binomials as well. All right, let's flip your graphic organizer over and do some practice problems. All right, so in 13, set up your tic-tac-toe board. Okay, so setting up your tic-tac-toe board, you should have x squared, positive 56, and my checking term is negative 15x. Okay, so notice I always keep my signs with everything. Again, the only way I'm getting x squared is x times x. Now, factors of 56 would be 1 times 56, 2 times 28, 4 times 14, 7 times 8, and what do I do? Again, my trick is always start with the two closest together. So I'm going with 7 and 8, and if I do 7 times 8, that does give me 56. However, take a look at what we got here. Yeah, I have a positive 56 here, but I have a negative middle term. So I'm going to do a negative times a negative. So this sign always tells me that my signs are the same. I look here, this tells me they both need to be negative. So I'm going to do negative 7 times negative 8. That's still 56. When I multiply across, that gives me negative 7x and negative 8x, and I check it by adding. Is negative 8x plus negative 7x equal to negative 15x? Yes, it is. So I have success. Here's my one factor, which would be x minus 7 times the quantity of x minus 8. And again, you could put x minus 8 times x minus 7. Order there doesn't matter. Again, set up your board. Okay, in the last problem, this sign right here was positive, which told me that my two signs were going to be the same. Since it's a negative here, the only way I'm going to get a negative 18 is a positive times a negative. So this time my signs are going to be different, meaning one's a positive here and one's a negative. The only way I'm getting x squared is x times x. My factors of 18 would be 1 times 18, 2 times 9, 3 times 6. So what am I going to do? I'm going to start with 3 times 6. Multiply across, that's 3x, and negative 6x adds to negative 3x. Not good. So what am I going to do here? I'm going to back up, and I'm going to try 2 and 9. I'm going to put 2 here and 9 here. Multiply across gives me 2x and negative 9x. And then I add, and sure enough, this plus this is negative 7x. So again, I've got my answer on the diagonal. So one of them is, let's see here. Sorry, gotta switch tools. It would be x minus 9 times the quantity of x plus 2. So sometimes kids ask, why do they have to circle on the diagonal? You're going to see why in the next type of factoring. Let's return to the front of your organizer and look at the last type of trinomial, which is where it's in the form of ax squared plus bx plus c, but this means that my leading coefficient is something other than 1, okay? So this is probably our most complicated form. What you want to first do is see if you can factor out a GCF. So as I look at this, there's nothing that goes into 6, 13, and 5. So my only option here is to go to my tic-tac-toe method, since it's a trinomial. First term, last term, which is positive 5, and my checking term is still 13x. Now, previously I just said, well, x times x would be x squared, but now I've got this coefficient of 6. So we've got to list our factors of 6. It could be 1 and 6 and 2 times 3. Again, I always start with my two closest to each other. So I'm going to try 2x times 3x gives me 6x squared, and hopefully this combination is going to work. It's really just some trial and error. Now, the rest of this is identical to before. 5. My factors of 5, well, fortunately, that's only 1 and 5. So I'm going to put a 1 here and a 5 here, but I want to remind you, I said when this is a positive, the only way I'm getting a positive 5 is a negative times a negative or a positive times a positive. This tells me my signs are the same. I look at this one, since it's a negative, I'm making both of these be negative. Okay. Now I'm going to multiply across and see if my combination here works. This gives me negative 2x and negative 15x. I check it by adding. That's negative 17x. It doesn't work. So there's a couple of things I can try. I can just try changing my order. I had -1 and 5, -5. I'm going to flip-flop them and make it -5 and -1. Now, as I multiply across, this is -10x. This is -13. Excuse me, -3x. I was getting excited because I see I have one that works. When I add, I get -13x. If that didn't work, though, what you would do is go over and cross out this 2 and 3 and try 1 and 6 and try all your combinations again. Now, this is why it was so necessary to circle on the diagonal, because my one factor is 2x minus 1, and my other factor is 3x minus 5. All right, flip to the back and let's go through the remaining practice problems. So in this one, again, I begin by looking to see if I have a GCF. There's nothing that goes into 4, 20, and 25, and it goes x squared, x, no x at all. Okay, so my factors of 4x squared, well, this could be 1 and 4, or 2 times 2. Again, I'm always going to start with the two closest together. And then I need factors of 25. Well, that could be 1 and 25, or 5 times 5. Look at my signs. This is a positive, tells me my signs are the same, so both positive or both negative. I look here, this tells me they're both positive. So I like to start again with the two closest together, so I'm going with 5. Multiply across gives me 10x, across gives me 10x. Check it, does it add to 20x? It does. Okay, so I've got it. This would be 2x plus 5 on the diagonal times 2x plus 5. Occasionally, you'll see this written as 2x plus 5, all to the second power. For this next one, pause the video, try it on your own, and then check your answers. So I've set up my board. I'm using 5x times x gives me 5x squared. Factors of 6 are 2 and 3 and 1 and 6. I try the two that are closest to each other. So I'm going to try 2 and 3 because I have a positive here and a negative here. This tells me signs are the same. This tells me they're both negative. So I'm doing -2 times -3 gives me positive 6. I multiply across, and I already can tell this is not going to work. That gives me -10x, and -3x adds to -13x. So first I start flip-flopping the 2 and the 3, and I remultiply. So if I put 3 here and 2 here, I think I have a winner. This is -15x, and -2x does add to -17x. So my factors are 5x minus 2 and x minus 3. How do you check it? You multiply, distribute back together. Okay, so in 17, again, always get in the habit of looking for that GCF. I spot that these are all even. So my first step is going to be to factor out a GCF, which looks like it's at least 2 here. So if I divide everything by 2, okay, so I'm going to remind you, GCF first from the front of your graphic organizer. This would give me 9x squared plus 18x plus 8. Okay. Now, potentially, this is going to factor into 2 more binomials using the tic-tac-toe. But off on the side here, I'm going to set up my tic-tac-toe board. 9x squared, positive 8, and my checking term is the 18x. So factors of 9 are 9 and 1 and 3 and 3. I always start, again, with the two closest together, and I hope that they work. I do my factors of 8, which are 8 and 1, 2 and 4, and I start with my two closest together. How about my signs? Well, positive here means they're the same. This means they're both positive. So I multiply across, gives me 12x and 6x. Yes, I got it on my first try. So my one factor is 3x plus 4, and my other one is 3x plus 2. If I would multiply this all back together here, I would get what I originally started with. This is the final one that we'll do together. So again, I encourage you to give it a try on your own. First, factor out the GCF. Pause the video, press play when you're ready to see the solution. So in this one, I don't really see anything that goes into both 6, 25, and 4, but if you notice, my variables go x to the third, x squared, and x. They need to go quadratic, linear, no variable at all. So I'm going to begin by factoring out x, which is my GCF, which gives me 6x squared plus 25x plus 4. Now, this potentially factors again, since it's a trinomial, using my tic-tac-toe method. All right, factors of 6, 1 and 6, 2 and 3. Starting with the two closest together. Factors of 4 are 1 and 4 and 2 and 2. I will go with 2 and 2. Everything's positive, so I know I'm going to need to leave everything positive. Multiply straight across gives me 4x and 6x. That only adds to 10x. If I flip-flop this 2 and 2, not going to help me. So I'm going to erase and say 2 and 2 are no good. So what if I try 4 and 1? Well, I know I need to make this pretty big because I need it to add to 25. So if I put the 1 on the top, 4 on the bottom, and multiply across, gives me 2x and 12x, and that only adds to 14. All right, so what's that tell me? Now I got to go back and change this 2 and 3. So if I change the 2 and the 3 to a 6 and a 1, how about I put the 1 here and the 6 there? Because I know I'm trying to make my sum be larger. Multiply across gives me 1x and 24x, and I think I'm in business. That adds to 25x, so I have my two factors. My one is 1x, or just x, plus 4, because it's positive. Could have put a plus there. And 6x plus 1. This is factored. Now I do have to tell you that if you had factored, tried to factor using tic-tac-toe, and you couldn't find anything that worked and you exhausted all combinations, then you would just stop at this line here. You'd factor out your GCF, and that's as far as it could go. Okay, you definitely need to practice this. This skill requires quickness and accuracy. Good luck.